Hi guys, I want to talk about velocity versus time graphs today and how we can get some formulas from those that are handy in what we do. The position versus time graph versus velocity versus time graph, the difference is that you get a velocity on the vertical axis instead of position. So if you remember the position versus time graph, we could get the average velocity by taking the slope. Well, here we have the velocity at any point in time for all of these. And remember, velocity is speed and direction. So the direction is indicated by the sign of the velocity. So anything above the axis is going in a positive direction. Anything below the axis is going in a negative direction. So the objects that are signified by the blue and the green lines on this graph are both moving in a positive direction. The object signified by the red line is starting in a positive direction, but moving in the negative direction by the end of the 5 seconds of the motion that's graphed. We have a couple formulas that are handy to use from this. One of them is finding the average velocity in a different way than we did with the position versus time graph. This particular method only works if we have a straight line, and a straight line on this graph means that we have a constant acceleration. And we'll talk about that in a little bit. So if we have a line that curves, or if we have multiple lines that do not maintain a straight form, if they have corners or something, we can't use this particular idea. But if we have a straight line and we have constant acceleration, then we can just look at a velocity versus time graph and find an average velocity for that period of time where it maintains a straight line. For example, on this blue one, we see that it starts at rest at time equals 0, and right here, and then it goes to 20 meters per second 10 seconds later. All right, the average velocity then would be in between those two, and in fact, because it's a straight line, the average is exactly at half the time and exactly at half the speed at 10 meters per second. And so that's just taking the average between 0 and 20. So it's just like taking an average of any two numbers. So average velocity formula in this is initial velocity plus final velocity divided by 2. So here we're doing 0 plus 20 meters per second over 2 equals 10 meters per second. And that's our average velocity. It happens to occur when it's halfway into its motion at 5 seconds. We can do the same thing here with the red one. And the red one, we'll just use this purple. It starts at 10. So initial velocity is 10 meters per second. Final velocity is negative 20 meters per second. And it doesn't matter that it took 5 seconds instead of 10 seconds. All we have to do is find the average between those two. So the average velocity is 10 plus negative 20 divided by 2. Well, 10 plus negative 20 is negative 10 divided that by 2, and we get an average velocity of negative 5 meters per second. And that's exactly halfway between those two. We could do the same thing with this one, but since the velocity doesn't change, the average between the beginning and end is still the same, so 12.5 meters per second. So this is a handy formula, and we'll use that formula in some, we won't use it exclusively, we'll probably insert it in to develop some other formulas later in the unit. But we can find the average, but it only works. We have constant acceleration. That's critical. And constant acceleration means we have a straight line. Speaking of those straight lines, when we talk about the velocity versus time graph, the slope, the rise over run, well, in this case, the rise is a change in velocity versus the change in time. And that is our average acceleration formula. So acceleration is delta V over delta T, or final velocity minus initial velocity over time. So we can find the acceleration for a given line. And this would work for any type of situation. So for example, here, the initial velocity is 15 meters per second. Here, it's 0 meters per second, final velocity. In other words, this object, whatever this is graphing, starts at 15 meters per second and slows down to a stop after 8 seconds. And it's got a constant acceleration down to 0. Remember, acceleration doesn't mean just speeding up, it can mean slowing down. So our average here is final velocity, 0 meters per second, minus 15 meters per second, divided by 8 seconds. All right, so negative 15 ace meters per second, which is meters per second squared. I'm running out of room here, which would be 1.88 meter per second squared. All right, so that gives us the ability to find an average. Now we could do, this would work actually with other situations as well. It could work on a curve, for example, where we go right here for a final velocity, which would be negative 12.5 meters per second, and our initial velocity is 10 meters per second, and it took place over 10 seconds. So we could find the average velocity, average acceleration in this. And that would basically be the average slope of this. In other words, well, let's do the math here. Negative 12.5 meters per second minus 10 meters per second over 10 seconds. So you get negative 22.5 meters per second over 10 seconds. So negative 2.25 meters per second meters per second squared. That could also be found if we just drew a dashed line right there. That's the average slope, or it's also the tangent at some point. Okay, so when we deal with that, we're not going to deal with this particular sequence of motions, but the formulas that we have here then are your average velocity, which is found by taking the sum of the initial and final velocity divided by 2. This only works when acceleration is constant. And then we also have, let's give you a better color here. We also have acceleration. Average acceleration is change in velocity over change in time. So it gives us a chance. This works anytime. So now here's the nice thing, and we'll use this to our advantage at some point. When we have a constant acceleration, that can also be treated as an average. So you will see these two formulas used in different ways in combinations with others when we have constant accelerations. And so those additional formulas that are coming are pretty handy. All right. So those are the two formulas that are gotten from a velocity versus time graph, and we'll talk more about how we use formulas in solving situations based on this type of thing in the next lesson. Thanks a lot. Have a great day.